Well, can you define what covalent bonding is? I just said it a few minutes ago. Put it down on the notes. What's covalent bonding? Sharing of electrons, and we learned something new about it. That's what you learned in physical science, sharing of electrons. What was the new thing you learned earlier in this class? Today. What else are you sharing? Okay. All right. So you could say the atoms that are doing covalent bonding play well together. Okay? And you could say the elements that are involved in ionic bonding do not play well together. Okay? So what happens with little kids when they don't play well together?
They fight.
Okay? What else?
They cry.
Huh?
They hate each other.
They separate.
They go and tell their mama.
They intervene.
All right. So they're playing with their toys and they separate. And what do they do with the toys?
Throw them. Oh, little
You
kid.
take them away.
Yes. Thank you. Finally got around to somebody who gave me the example I was looking for. Ionic bonding is where one or more elements or one or more ionic polyatomic ions are called. Basically take the electrons with them and the others lose some electrons or they don't have all the electrons they need. Okay? So we're going to start with the simplest of ionic bonds and talk about monoatomic ions. Okay? Monoatomic means single atoms that become ions. All right? So single atoms that become ions do so by giving up or gaining electrons. We did that in the last unit. In fact, there was a question on the test about forming an ion of vanadium, right? And what did vanadium do to form the ion on that test? Anybody? I know there's a couple people got it right. No? How do you get a 5+ charge? We did it in the lab. We had you have to take away 5 electrons. Okay? So you write the complete orbital notation, then you take away 5 electrons. Okay, that's how you get vanadium 5. All right? So in ionic bonding, you have positive and negative ions. Some are positive, some are negative, and the bonding occurs because of the opposite charges. And one way to think about it, is to say that ionic bonding comes because some atoms, if we're talking about monoatomic ions, and give up electrons, some take them, and particles are held together by opposite charges. Okay, so by putting them together with opposite charges, tends to create a stability. Things that are charged not by themselves have a certain instability by virtue of the fact they do have those charges. Put a positive charge with a negative charge in an equal ratio, that is enough positive charges, enough negative charges, so they kind of cancel each other out, you get some stability as a result. Okay, covalent bonding occurs because by sharing electrons, you create stability. The universe likes stability. Okay? Stability is, when you understand the whole idea behind stability and entropy are pretty much the same thing in a simple sort of sense. And the universe is, one of the thermodynamic laws of the universe is tending toward entropy. Okay? So if you ever take physics, you can remember I told you about the law of entropy. Okay? All right. So if we're going to look at things like magnesium and chlorine, magnesium has an orbital notation that looks like this. And chlorine has an orbital notation that looks like this. Okay. Now, chlorine would be a lot more stable if it had one more electron to fill up this orbital down here. Fill up this sublevel and fill up this primary level. Okay? Orbitals are more stable when they have 2 electrons. Sublevels are more stable when they are full. Primary energy levels are more stable when they're full. So the most stable we can make chlorine is to add an electron right here. That does all 3. Are you with me on that? We're trying to create a more stable universe, right? Or the universe is creating it. We're not really doing it per se, but okay. Now, magnesium would be more stable if it had a full outer energy level, but that means it either has to gain 6 more electrons and create a 3p sublevel, or it could just get rid of these 2, and then what remains is a full level, right? Which one's easier? Is it easier to give up 2 or gain 6?
Give up 2.
Okay, so magnesium is going to want to give up 2. And so I have 1 electron to go here, but I need to give up another one, so I need another chlorine. So I need 2 chlorines to balance out magnesium, in a sense. Okay, that'll create a 2 plus charge in the magnesium, a 1 negative on the chlorine. If I've got 2 chlorines, then I'll have 2 negatively charged chlorines, and 2 negatively charged chlorines balance out 1 2 positive charged magnesium. Y'all with me? We did all this in the last unit. I'm just trying to make sure you're kind of getting the concept here. Trying to make sure you're up to speed. Is there anybody who isn't up to speed on this, that doesn't understand what I'm talking about? Okay. Since nobody's saying anything, I'm trusting you.
Chlorine?
Huh?
You need 2 chlorine.
Yeah, I need 2 chlorines. Because the chlorine here only needs 1 electron. If we put 1 electron down here, that creates a 1 negative charge. I can't put two electrons down here. That doesn't fill up orbitals, sublevels, and primary levels. Okay? Magnesium can get rid of these 2 and have a full valence level. So that's what's going to make everything more stable. All right? So I can actually take and cross out this electron here and drop it down here, draw out another chlorine, cross out this one and drop it down here. I could do that. I think, did we do that in the last unit? Okay, I'll show you how it works. But let's use Lewis dots for this, okay? How many valence electrons are there in the magnesium atom? How many valence electrons? How many valence electrons in the magnesium atom?
8.
That's the electrons in the highest primary energy level. 2, they're right here. There's the highest energy level, 3. There are 2 electrons in 3.
Because last time you did it, there's, you can use 2 different energy levels, whatever. Never mind.
Yeah, I thought, I thought you did like the highest. Never mind.
Well, I'm getting to the same thing I was describing here by starting with the ground state for both atoms, if that helps. How many electrons do I put around the chlorine for an electron dot formula?
5,
Really?
6,
8.
Really?
7, 4.
3 is the highest energy level.
Yeah, so.
And in 3, I got 1, 2, 3, 4, 5, 6, 7. Some of you finally said 7, but we went through 5, 8, 2,
Okay, I thought you said is you use the highest energy level.
Say again?
So you use the highest energy level.
Yeah.
But that's 2 energy levels.
No. This P and S are sublevels. The highest primary energy level is 3. And there are 2 sublevels within 3. So all of this right here makes up all part of the same primary energy level. When physical science, when you were drawing those big circles and putting electrons on them, you were representing primary energy levels. Okay?
So why is that one just 1 and that one is, why is that one 2 and that one 7?
Because they're 2 different elements.
Like why isn't that one 8 since you, because you're using 2 sublevels, like what was using 4 there.
Yeah, I'm kind of lost for the question. So.
It's because that's the third sublevel of magnesium.
I mean, the third primary level.
Listen, honey, he's asking why are you using 1 level on magnesium and 2 on chlorine?
That's the highest one on magnesium.
Because chlorine has an extra sublevel here. That's the structure of chlorine. Chlorine has 17 protons, where magnesium only has 12. So to get a ground state atom, chlorine also has to have 17 electrons. So we have to add 1 more sublevel to have a place to put those extra electrons.
Okay.
They can't just, you have to have the same number of protons and electrons for a ground state atom. And they have to arrange themselves in the right way for it to all work. It just doesn't, they just don't fly around there willy-nilly. Okay, they actually have an arrangement. Okay? All right. So, if I take one of these electrons from magnesium and move it over here, then chlorine is going to have 8 electrons. And that was going to fill up its valence level, making it more stable. Does that make sense? Okay. Chlorine originally had how many electrons? 7. How many would it like to have to be as stable as it can be? 8. Where do I get an extra electron from? Magnesium. But are you still lost? You're okay? Okay. So if I do that, then let's do this. Then I'm going to have chlorine with 1, 2, 3, 4, 5, 6, 7, and now 8 electrons. Huh? Oh, sorry. How many protons does chlorine have?
Where's 17.
17. And how many electrons did it originally have?
7.
Total electrons. 2, 4, 6, 8, 10, 12, 14, 16, 17 electrons. A ground state atom has an equal number of protons and electrons. So this atom has no charge because the protons and electrons are the same. Positive charges equal negative charges. They cancel each other out. Got that? Okay. So what I did was, instead of having 17 protons and 17 electrons, I just added an extra electron to this chlorine. How many protons does chlorine have?
Do what?
We didn't do anything with anything with the protons. It still has the same number of protons. Protons don't change, not with chemical changes. All right. We just did nuclear, and I know nuclear we can change the number of protons, but we have nothing going on here to put an extra proton in here. So if it has 17 protons to start with, still has 17 protons, and we're done. Because in chemistry, chemical reactions, you don't change the nucleus, you only change the electrons. Got it? All right.
So what do you like to add magnesium on that?
Well, we'll get to magnesium in a second. Just hold that thought, okay? What I'm trying to do is figure out how many electrons, how many protons I have since I've added an extra electron. 18 electrons. How many protons? 17. So what charge does this have? -1. Okay? So we started out with 17 protons plus 17 electrons, so 17 positive charges plus 17 negative charges, that results in no charge. Right? So then this is, when we put these together, we get something that is, I don't have room to write it, but this is neutral. Okay? But now down here I added an extra electron. I moved an electron from magnesium to chlorine. So now instead of 17 protons and 17 electrons, I've got 18 electrons. Right? So I've got 17 positive charges from the 17 protons. Got 18 negative charges from the 18 electrons. What's the overall charge here? 1 negative. Okay? So as a result then, we have some kind of particle that has a 1 negative charge. Okay, I kind of squeezed it in there in tiny little letters, but the word is charge. Okay? So chlorine now, with this extra electron on here, is not a chlorine atom anymore. It's now a chlorine ion, and we call it chloride. Negatively charged monoatomic ions have an IDE ending in their name. And we're going to put that negative charge on here, right there. Okay? I got to show the negative charge. If I don't show the negative charge, I'm not really being fair about what I've got. Okay? All right. Magnesium up here just lost 1 electron. But what did we say? How many electrons did we say it wants to lose? 2. So I want to get rid of this other electron. Where's it going to go? Another chlorine. We need another chlorine. So let's draw out another electron dot formula for chlorine. Okay. And show how we can move that electron from right here to right there. Okay. So we started out with 7 valence electrons, 7 dots around the central atom. 1, 2, 3, 4, 5, 6, 7. But we're going to add another one to it. That makes it 8 electrons, which gives it some more stability with the electron cloud, but it also changes the charge because those particles moving around have a charge. So what else do I have to put on this symbol here? A negative symbol. Okay, so that's a chlorine ion. It's not a chlorine atom anymore. Chlorine atoms have an equal number of protons and electrons. This has an extra electron on it. Yes? All right, now, over here, I've removed 2 electrons from magnesium.
So magnesium is gone from
Okay, so we started out with 2 electrons. Whatever we draw down here is not going to have any electrons around it. We got rid of them. Now remember, that's the valence electrons. We still have all those we're not going to show. Okay, but we have magnesium with no dots around it. But if I got rid of 2 electrons, it's not a magnesium atom anymore. What kind of charge does it have? 2 negative. Okay, magnesium started out with 12 protons and 12 electrons. And so when we put those together, we have something that's neutral. Okay? But we took away 2 protons. So how many protons does this have now?
We can't see all that.
10. 10 protons plus 12 electrons. That's 10 positive charges and 12 negative charges. And so when you add the charges together, what kind of charge do you get? 2 positive. I love it. Yeah. Okay, well, he just went to the restroom. As soon as he comes back, I'll do that. All right. I understand. I know he wasn't feeling well. Thank you. All right. So when we add those together, 10 positive. Wait a minute. Is that right? I took away 2 electrons. I've added the wrong thing. This is 12 protons and 10 electrons. Y'all didn't tell me I did the math wrong. Where are you? Well, y'all got to pay attention here and help me out. I did the math wrong, didn't I? Let me do the math down here. Okay, so it's 12 positive charges and 10 negative charges. Okay, what does that come out to be?
Negative 2.
2 positive. Okay, because I took away 2 electrons. I just didn't write it down right. Okay. All right. So now we don't have a neutral compound anymore. We now have an ion with a 2+ charge. Okay. An ion with a 2+ charge. So this magnesium now has 2+. Not just plus. You have to tell me how much plus. How much negative. A single negative is 1 negative. Okay? Alright. So what we have now, we have a 2+ charged particle. And we have 2 1 negative charged particles. If we put them together, what is the resulting particle charge going to be?
0.
0. So we're going to put all this together to make one common compound.
Magnesium chloride.
It's called magnesium chloride. That's true. So what we actually have then is we have, let me use this right here. Say we have 1 magnesium 2+, magnesium 2+. We're going to add that together with 2 chlorines that have a negative charge. And when we do that, we're going to have a compound that has no charge. Okay? Because we're going to put 2 positive charges with 2 negative charges. So we're going to have a compound MgCl2, but there's no charge up here because we just cancel it out by putting them together. Got that? Yes? Kinda. Well, let's let you practice then.
That's taking notice. Practice.
Okay, so there's your class practice. Class practice. So you got to use pictures to tell a story here.